Hello grade 7, welcome to math videos. Our lesson for today talk about how to solve the first degree inequality in one unknown. Before, we had studied the substitution set and the solution set in equation, which also the same idea in the inequality. If you remember, the substitution set is a set which is the values of the unknown in the equation or in the equality belonging to it. And the solution set is a set of the elements which satisfy the equation or the inequality. For example, find the solution set of the inequality x plus 3 less than 5. If the substitution set is set of elements -1, 0, 1, 2, 3, then represent the solution set on the number line. First, substitute for the value of x in by each element in the substitution set. Like when x equals -1, the left hand side equals what? -1 plus 3 equals 2. So 2 less than 5 is a true inequality. So I can say -1 is a solution to the inequality. The same idea when x equals 0. So 0 plus 3 equals what? Equals 3. So the left hand side equals 3. So 3 less than 5 is also a true inequality. So 0 is a solution to the inequality. At x equals 1, left hand side equals 1 plus 3 equals 4. So 4 less than 5 is also true inequality. So I can say 1 is a solution to the inequality. When x equals 2, the left hand side equals what? 2 plus 3 equals 5. If 5 less than 5, it's wrong because 5 equals 5. So 2 is not a solution to the inequality. The same idea, at x equals 3, the left hand side equals 3 plus 3 equals 6. 6 less than 5? Wrong. It's wrong because 6 greater than 5. So 3 is not a solution to the inequality. So the solution set is -1, 0, and 1. And take care, the solution set is subset of the substitution set. Now, don't forget, represent the solution set on the number line. Only draw the number line and above each element here, only put a point above each element. This method is longer and not easy, and it may be not impossible if the substitution set is infinite set. So I will use either method to find the solution. This method requires studying the properties of the inequality. Properties of the inequalities is first, 6 greater than -9 is a true inequality. So if I add 2 to the both sides of the inequality, we get 8 greater than -7. It is true inequality. So if A greater than B, then A plus C greater than B plus C. So in general, we can add a constant number to both sides of the inequality and without a change the sign of the inequality. Here, if I subtract 7 from the two sides from the first inequality, we get -1 greater than -16. It's true inequality. So if A greater than P, then A minus C greater than P minus C. So in general, we can subtract a constant number from the two sides of the inequality without a change the inequality relation. Here, if I multiply the first inequality by 5, so 6 times 5 equals 30, and -9 times 5 equals -45. So 30 greater than -45, it's also a true statement. So if A greater than B and C is a positive number, then AC greater than PC. So in general, multiplying the two sides of the inequality by a positive number, again by a positive number, doesn't change the inequality relation. If I divide the first inequality by 3, okay, we get 6 divided 3 equals 2, and -9 divided by 3 equals -3. So 2 greater than -3, it's also a true inequality. So if A greater than B, C is a positive number, then A divided C greater than B divided C. So in general, also, dividing the two sides of the inequality by a positive number, again with a positive number, doesn't change the inequality relation. Here, I will multiply the first inequality by a negative number. Like here, 6 times -1 greater than -9 times -1. So 6 times -1 equals -6, and -9 times -1 equals what? Equals 9. Oh, -6 greater than 9? It's false, because -6 less than 9. So take care here. If we multiply the two sides of the inequality by a negative number, then we change the sign of the inequality to the opposite sign. Like here, -6 greater than 9, it's false. I will change the sign of the inequality to what? To the opposite sign to make this inequality true. Last one. If I divide the first inequality by -3, we get 6 divided by -3 equals -2, and -9 divided by -3 equals 3. So -2 greater than 3? No, it is false. Because what? Because -2 less than 3. So in general, if we divide the two sides of the inequality by a negative number, we change the sign of the inequality to the opposite sign, okay? Because I will divide by a negative number. Exercise number 1, find the solution set of the inequality x plus 2 less than 5 in each of the two following cases, okay? First, if x belongs to z and if x belongs to natural number. And the first, then represent the solution set on the number line. Please don't forget it. And the first, my inequality here, x plus 2 less than 5. I need to put the variable in one side, okay? So here I will subtract -2 from the both sides of this inequality. So x plus 2, -2 equals what? Equals x. And x minus 2 equals 3. So x less than 3. Another method. Here I need to separate between the variable and constant. Like the constant here is positive 2. I need to move the constant to other side with the opposite sign. The sign of the constant here is positive, so I move it with the opposite sign with negative. So x less than 5 minus 2. So x less than 3, the same solution, okay? So the solution set when x belongs to integers number. I mean all integers number less than 3. You know the integers number consists of z positive union 0 union z negative. So all integers number less than 3, I mean 2, 1, 0, -1, -2, and so on, because integers number in infinite set. And when I represent it in the number line, I will draw the number line and put a point above each element in this set. Then I will draw arrow in the direction of z negative, because I said -1, -2, and so on. The solution set when x belongs to natural number, then I mean all natural number, all elements less than 3 in natural number. Like what? Like the solution set 2, 1, and 0, because natural number starting from 0. And the same idea, I will represent it in the number line, only draw a point above each element here. Another exercise, find the solution set of the inequality 2x minus 5 greater than 5 in each of the two following cases, okay? And the same idea again, but the solution set if x belongs to rational number and if x belongs to integers number. So here my inequality 2x minus 5 greater than 5. I need to separate the variable and constant. So my constant here is -5. So I need to move the -5 to the other side with the opposite sign. The sign of the constant here I said negative. So the opposite sign is positive. So 2x greater than 5 plus 5, okay? So 2x equals what? Equals 2x, greater than 10. Now I will divide by 2. So x greater than 10 divided 2, x greater than 5, okay? So my equality, after I simplify it, x greater than 5. Now I need to find the solution set when x belongs to rational number. Here I have many rational number greater than 5, and it is difficult to list all these elements. So I will use the description method to write the solution set like this. The solution set equals x where x belongs to rational number and x greater than 5. It's called description method because it is difficult to list all elements. So I will use this method. But when x belongs to integers number, x greater than 5, which integers number greater than 5, 6, 7, 8, and so on. So the solution set is 6, 7, 8, and so on. Okay? Last exercise. Find the rational number. Find in rational number the solution set of the inequality 4 minus 2x less than or equal to. The same idea here. Again, I will separate between the variable and constant. Where is the constant here? 4 or -2? The constant here is 4. So I need to move 4 to the other side with the opposite sign. So -2x less than or equal -4 plus 2. So -2x less than or equal -2. Then now I need to divide by -2. But take care, here I will divide by a negative number. So I must change the sign of the inequality, because I will divide the both sides with a negative number. So -2x divided -2 greater than or equal, okay? The opposite sign. Greater than or equal -2 divided -2. So x greater than or equal 1. Now I can write the solution set in rational number. Remember, I said what? Rational number. So I will write the solution set by the description method. So the solution set equals x, where x belongs to q and x greater than or equal 1. Last one. Find in integer number the solution set of the inequality -3x greater than or equal to -11 and less than, I'm sorry. Again, find in integer number the solution set of the inequality 3x minus 5 greater than or equal -11 and less than 4. Then represent it on the number line. Here, this inequality consists of 3 sides. The same idea. I will separate between the variables and constants. Constant here is -5. So I will add 5 to the both to the 3 sides, okay? I will add 5 to the 3 sides. So -11 plus 5 equals -6 and -5 plus 5 equals 0. 4 plus 5 equals 9. So 3x greater than or equal -6 and less than 9, okay? Now I will what? I will divide by 3. I will divide the 3 sides by 3. Then -6 divided by 3 equals what? Equals -2. 3x divided 3 equals x, and 9 divided 3 equals 3. So x greater than or equal -2 and less than 3. So the solution set here, I need to find the solution set in integer number. So the value of x equals greater than or equal -2 or equal, so I take -2. So -2, -1, 0, 1 and 2. I will not take 3 because only less than 3. So the solution set is -2, -1, 0, 1 and 2. The second part from this question represent it on the number line. I will draw the number line. And I put a point above each element. Now, thank you for your listening. I wish you have a good idea about this lesson. Goodbye.